I'm going to give you three graphs. You're going to tell me which graph represent the phenomena of friction.
This one. First of all, let's start with this one. This one might be the easiest to explain. We all know it's easier to keep something moving than to get it to start moving, right? This scenario is saying is that when I increase my applied force, the force of friction will increase linearly, right?
Yes.
But there's a problem here. And the problem is that if I keep increasing my force, the force of friction will keep increasing. Nothing will ever move in the world.
Stop rambling. All right. So only one sentence.
Okay.
All right. One sentence is there any maximum kinetic friction?
No. Well.
Oh, is there any maximum kinetic friction?
No. But the biggest problem with this one,
yeah,
nothing would ever move in this world.
Right.
Because no matter what force I apply, the friction will match it. At best, I can get something to go at constant velocity. At best.
At best, right.
At best, right. But I can never accelerate something.
All right. Yeah, that is true. Yeah. That's one contradiction. Another contradiction is there any maximum kinetic friction you can identify on this graph?
No. And also kinetic friction has to be constant, and there's nothing constant.
So there is no maximum kinetic friction possible on this graph.
You mean maximum static friction?
Maximum static friction.
Yeah.
And that is 39.2.
Yeah.
So contradiction.
So this one is out for two reasons. Nothing could ever accelerate in this world.
And number two?
And number two,
there is no such thing as maximum static friction.
Or more importantly, the coefficient of kinetic friction doesn't stay constant.
And the coefficient of kinetic, three reasons.
Yeah.
So three reasons.
Yeah.
This object will never accelerate. Yeah. Number two, there is no maximum static friction here. Okay, because there is no maximum static friction. That is 1.2. And number three, there is no
the kinetic friction. No, there is. Even if there was kinetic friction we know has to stay constant.
Yeah, so there is.
But nothing is constant.
So that's
so this one is out of the game.
All right.
That doesn't mean things won't move in this world. We said things will move.
Yeah, move with constant velocity.
But they won't accelerate. That's what we said.
Okay, so this one.
Important
What's wrong with this one?
Number three. This one.
Yeah.
Okay, so first of all, same problem. The kinetic friction is obviously not staying constant, right?
No,
it's changing. That's one problem. But this one looks far more innocent than this one. At least you can get things to accelerate in this world.
It's worse than that one.
Well, but there's another problem.
See, over here,
you can't make a distinction between the coefficient of static friction and coefficient of kinetic friction. Why? Because remember, the whole idea of coefficient of kinetic friction is that it's smaller than the coefficient of static friction, right?
Absolutely.
Because it should be easier to keep something moving
than it is already moving.
Right, than to get it started
because
moving.
Because there is no inertia. Okay,
right, but nice. Here clearly you can see that every point here, the static and kinetic friction. This is not even a function. Well, no, it is a function. It's
not a one-to-one function.
It is a function because function has to pass the vertical line.
So this is not a one-to-one function.
It's not a one-to-one function, that's
because
right.
Because it doesn't pass the horizontal test.
That's right, yeah.
Okay.
But the big idea is that here you cannot distinguish between kinetic and static friction.
Okay.
Because, as you can see, kinetic friction should always be smaller, right?
Okay.
And it should be constant.
Therefore, the right choice is this one now. 0.4. Now you graph it. It's like a pie.
Yeah.
Pi, this would be circumference and this would be diameter, and you get 3.14.
So first point is the origin.
0, 0, 10, 10.
You mean 30, 30?
Oh, 30, 30.
Okay, so 30, 30 right here.
Yeah.
Okay.
Yeah, we can say 10, 10, 20, 20.
Yeah, we can fill those in also. Okay, and then suddenly as soon as we get to 40, we connect the dots. Okay, and there you go. So this is my maximum static friction and this is my kinetic friction.